folks. Today I'm going to be talking about my Troy-built 12 horsepower chipper. Recently I knew that hadn't used this unit for maybe approaching a year, and I remembered that I hadn't changed the gasoline out, so I brought the chipper into my garage, and my intention was to come in and change out the valving. And normally the carburetor sits right here. It has been removed, so this would go up to the carburetor. And I added this extra plumbing here, so in the future I could just open a valve and drain the tank and make it a whole lot easier to drain the system gasoline and to keep it from going bad. Anyway, I took the gas out. It was a little yellowed, but no evidence of water in it. And I put in fresh gasoline, got it all hooked back up, and it was very temperamental about starting. I finally gave it a shot of starting fluid, and it took off, but still didn't run very well. So I took the carburetor. I thought, well, this time I've waited too long. I must have a bunch of material in the carburetor that needs to be cleaned out. So I took the carburetor out and cleaned it. And I've always had a problem with the original carburetor on this unit because of several factors. Let's take a look at this original carburetor. And there are a couple of things I wanted to show you. Hopefully, I don't know whether the light will pick this up or not, but there's actually a defect in the casting. This is not nice and smooth. And I know I've been into this once before, a year or two back, and I had to kind of goopy it up with a silicone sealer to keep the vacuum from leaking. And this is on the side. This is the throttle, main throttle, butterfly throttle. Also, I noticed that this is the choke side, and if I get the light right, perhaps you can see a small hole right here that my pencil is pointing at. This is a vent that goes basically through the body of the carburetor and down into the bowl to equalize the pressure inside the bowl to the atmospheric pressure out in the space. And you notice that this actually has a little hole here. Now, if we take a look at the replacement carburetor, you'll notice that this carburetor has a little brass or copper tube that goes back into that hole, and it extends past, when the choke is in a full closed position, it extends past this. Well, that may be a problematic situation in the old carburetor if this is missing, because when you're choking it, the pressure, air pressure behind this choke drops, causing the bowl to be in a slightly negative atmospheric pressure relative to the outside world, and it may cause it to pull in extra fuel that it really shouldn't do. It may be part of the problem that's leading to some of the hard starting. Also, the other reason, I'd had enough with this carburetor. I decided to buy this one and replace it. The other is that it has an adjustment for the main jet, and it also has an adjustment right here for the pilot jet. Both of these adjustments are missing on this carburetor. It's fixed. It does appear to have a pilot jet, but it just screws in. It's a fixed jet. You can't adjust it. And so I decided to go with a new carburetor. Well, when this carburetor was put on, the new carburetor, it still did not want to start. And finally, even though I had new fuel in it and a good clean carburetor, so I sprayed starting fluid in it. It sputtered a little bit, still did not want to start, so I was under the impression that something is wrong. And that's when I began doing further testing. So the next step was to try to figure out, take a look for the spark, check compression, see what was making this engine so temperamental. And the first step was I removed the cover over the valves and to check the valve clearance. Now you can say, well, I know exactly why this engine won't run. It doesn't have any rocker arms. Of course, those have already been taken off. This engine's been partially disassembled. What I thought was going to be a 30-minute repair job is turned into far more. Typical for one of my projects. So I checked the rocker arm clearance, and I believe the intake was 4 and the exhaust was about 8. Very reasonable, so there didn't seem to be any problems there. I then removed the spark plug, which is actually on the back side of the head here, approximately where my finger is at. And I did not have a cylinder bleed down test kit, but I could hook a air hose up to that, and I injected some compressed air into the cylinder with the unit up on top dead center. Again, I could hear some movement, a little bit of air coming up through, I guess it was leaking around the piston, coming up in from the crankcase up through this oil fill, but no leakage could be detected in the intake or the exhaust. So, of course, what's the next thing? Well, the next thing was to take the head off and see if there was something going on in the top end of the unit. So I went ahead and took the head off, and the head's just loose here. We'll just lift it up. This looks relatively clean because I've gone in with a brush, cleaned around the intake and the exhaust valve, also cleaned the top of the piston. There was carbon in there, but this engine has been used quite a bit, not at all unusual. So I was, tell you the truth, a bit disappointed. I didn't see anything obvious. I went ahead and took the keepers out, took the valves loose, looked at the seats, looked at the valves, and they looked pretty good to me. So I did go ahead and use lapping compound and lapped the face of the valves again and reseated them, and continued my search for, what is the problem here? All right, as this was the original position of the head gasket, and the only theory I've got right now, and it's certainly not conclusive, is right here is a dark area in the head gasket. You may notice it. I don't know if the light is right to catch that or not. And also, now this is right below the exhaust that comes out the engine this way into the muffler, which sits approximately where my hand is. When you flip this over, there is some kind of a strange pattern that shows up. The only theory I've got at this point is that maybe the head gasket is leaking slightly. For instance, if you take a look, let me get this out of the way, at the cylinder, and I don't know that you can see this, we may have to move the camera in. You can tell where the piston stops at the top, or where the compression ring stops at the top, but there's no groove there. And in fact, you can almost see the original finishing marks on the side of the piston, on the side of the cylinder, excuse me. And this engine hadn't been smoking, so I don't think that we have an issue with cylinder wear causing the compression to fall apart. There's another factor I might mention. I did say that I put a little compressed air into this cylinder. When you're doing that sort of thing, if it's sitting perfectly dead center, it probably will not rotate. But if it's a little off, we've got, well, in fact, I did a calculation here. If I had 100 psi of air on the top of this, I've got nearly 800 pounds of force pushing down on that piston. You don't want that thing to flip around with your finger stuck in there, or have a tool in there and have it come flying out of there. Okay, well, I guess we'll proceed with putting a new head gasket on. I'm going to use just a little electronic contact cleaner to spray the top and sort of de-oil the top of the cylinder head. And we'll go ahead and lay the new gasket on top. Of course, there's no directions that come with this, but it doesn't appear that there's an up or a down side as far as the gasket. We'll try to degrease the cylinder head mating surfaces. And here I'm just using a little bit of contact cleaner, just anything that'll cut the grease. Make sure and get this centered. Unfortunately, this particular head has no pins on it for automatically centering the head. Just looking with a light down here to make sure the gasket appears to be still in the proper location. We'll run these down lightly. Seems like my torque wrench had developed a little issue, so I got Old Faithful out here. And I see we were supposed to tighten these in certain sequence in 60 inch-pounds, which is 5 foot-pounds, which is pretty low for this device, but we will go ahead and do that. Just moving around. And then we're going to go to 10 foot-pounds. And we'll bring it to 15. Okay, our max is 20 foot-pounds, so this one is for real. Okay. I can't see any reason why we couldn't do a air pressure test. We had the cylinder head all bolted down and properly torqued, and I did a cylinder bleed down test using air injecting into the cylinder, and to my surprise the intake port, which is like this one, this is the exhaust, the intake is just on the other side. I could feel substantial air leaking from the intake valve. So when I looked at the gauge had moved over into this area that we call moderate leakage. So I knew I had a problem, and we've got to take a look at the valves on the engine. Okay, we've taken the head back off, and you see before you the intake valve, which was leaking. Just to spin it and look at it, I can't see an issue, an obvious issue. I was a little surprised that it's not shinier since I just lapped it, but unless the valve is warped or something, that seems okay. Here's something I think I had overlooked. If you see at the end of my pencil a dark area here, it almost looks to me like maybe gas is leaking out of the intake valve, and it's burnt that just a tiny bit inside there. Somehow I missed that when I had it first disassembled. I believe I will try to lap it again and see if we can get that valve to hold. Just putting a bit of grinding compound on the face of the valve. What I've done is just to turn the head upside down, excuse me, and pour a small amount of gasoline in here, and then insert my finger into the intake and exhaust port and see if it gets dry. It's not dry now. Well, okay, we've had some issues trying to get the intake valve to seat properly. Apparently it had been leaking in this area for some time, and it kind of eroded the seat, even though I couldn't see it. I've been working for a while to get this intake valve lapped, and probably if this happens again, it'll be time to replace this intake valve. So I decided to go ahead and I noticed a little bit of seepage with the exhaust valve, so I had only lapped it slightly, so I decided to go ahead and lap that valve a bit more, and since I noticed a little bit of seepage. So again, you know, what you saw before is just a repeat. This is a fairly tedious part of the process. Again, I just take a tiny bit of this valve grinding compound, spread it around the perimeter. The trick here is to remember to try to keep your hands just as clean as you can, and not to get valve grinding compound on the stem of the valve, because obviously as you're rotating it, then you're going to be causing wear in the valve sleeve, which you don't want. The wear has to occur on the seat of the valve. So I've inserted it. This technique works all right with an overhead valve engine. Obviously, if the valves were in the block, this technique would not work. But when you can use a drill, it kind of reduces the labor a good deal. I don't know how much I described before, but basically I just take the drill, run it at relatively low speed, push it in and out, push it in and out. Every so often I reverse it. The reason for pushing it in and out is that as you lift the valve, some of the grinding compound comes back on the surface of the valve that you're trying to grind. It has a tendency to leak out to the side, and usually I don't grind too long. After all, valve grinding compound is not that super expensive, so I try to keep it refreshed. It does seem to lose its ability to cut the metal fairly quickly. I guess it becomes contaminated with pieces of steel and so forth from the valve seat that you're grinding. And again, just smear it around the perimeter. Push the valve back in. Wipe my hands for the 15th time, and that intake valve, I thought I'd just about wear it out. I've had it in and out so many times. Contrary to what you might see on YouTube, this is not particularly a fast process. At least it isn't for me. Don't recall if I showed it before, but the typical way this is done is with a suction cup on a wood handle. Something like this stuck to the top of the valve, and then you move it back and forth. Needless to say, the drill saves a lot of time and labor when you can use that technique. Again, if you have the valve in the head of the block, this technique doesn't work. But don't pass up the opportunity to do it the easy way if you can. And again, as I look at that, it looks pretty good. I believe that we'll give it at least, I'll clean it, put all new compound on here, and try it at least one more time before we check it for leaks. I started working on this yesterday afternoon, and I worked on it this morning. It took quite a while before this intake valve wanted to seat properly. So don't get excited or try to work too rapidly. This part of the job is just about completed, finally. Let's get the keepers up here. I usually use just a tiny bit of wheel bearing grease to hold the keepers while I'm trying to put it all back together. I'll get my little junior size spring compression unit here. Obviously, if I were going to do this all the time, I would buy a smaller unit that would more nearly be the size needed for a small engine like this. But hey, I had this one. I didn't have to order another one, and it seems to be doing the job. So okay, let's see if we can again, I just get a little bit of grease on here to help hold the keepers in place while I'm messing with it. They, of course, have a tendency to want to fall off. Well, that one got away from me. Oh, there it is. This can cause you to say things that you don't want your mother to hear. Alright, I think that fit in there. Obviously, the thing you don't want to have happen is a spring and the keepers go flying across the shop and part of it disappear, or you spend the rest of the day hunting for the parts. That doesn't happen to the more experienced mechanics, but a do-it-yourselfer guy like me, unfortunately, it happens a little too often. Now we're going to repeat the test. I think we saw this before. Obviously, to keep putting the head back and forth on to check to see for air leakage is not a real good deal. So now to turn the head upside down, excuse me, and pour a small amount of gasoline in here, and then insert my finger into the intake and exhaust port and see if it gets dry. I think this gasoline is starting to get kind of dirty. It's been poured in and poured out. I think I've just about worn the gasoline out too. But anyway, all right. The intake valve feels good, and the exhaust valve also feels dry. Usually what happens if there's a tiny leak, gasoline will go down through the face of the valve seat and then slowly make its way down the valve stem, and the first thing to get wet is the valve stem. And then if it's bad enough, it starts dripping out of onto your cardboard here, making a real fire hazard. So if you're a smoker, this particular test is not a very good one. But it beats repeatedly putting the head back down on the engine and tightening it up and putting compressed air on it and see if you have any leaks. So far, so good. I'm going to give it a couple more minutes and see how things go. Okay, well, the leak test using gasoline, pretty well everything passed. So I can't guarantee that that pouring gasoline into that socket and top of the head and watching for leakage is an absolute test, good test for whether it'll hold properly or not. But it seems as though if it's tight enough that no liquid can get through it, why, it seems to be pretty well seated. So at this point, I'm going to go ahead, put the head back on the engine and torque it down, and I'll bring you all back when that's done. Won't put you through that torque process again, and we'll do an air test on it and see if it does any better this time on the air test. Okay, we've got after lapping the valves, reworking the valves, we've got the cylinder head back on, and we're going to try to do another cylinder leak down test to see if we've got any improvement in our situation with air leakage. So I'll hook a air hose here into where the spark plug goes. Again, I'm going to keep my fingers away from the flywheel. It shouldn't rotate, but it could once we get air pressure in there. And I'll need to calibrate this valve, which is pretty simple. I just turn the air pressure up on it. This is the incoming air. Again, this is the air pressure going into the cylinder when we get it connected, and we set it here in the yellow in the set point or set area. So now we hook through this quick connect. We'll hook air into the cylinder. Okay, as you see, we saw the air pressure going down. I can hear a hissing sound, and this gauge says that we're leaking, well, less, between probably 10 or 12%, which is really pretty good. I can feel no air coming out of the exhaust or the intake, and the air I hear hissing is actually coming up through the crankcase, so this is a little bit of blow-by past the piston. But that's really a good test, and it looks like we've got the problem with the valve leakage taken care of. Okay, we've made a little progress here, beginning to reassemble, got some of the tins back on the frame, on the engine, and I think at this point we'll I put the rocker arms on. I don't have the carburetor set and the exhaust system just yet, but I think this would be a good point to adjust the gap on the valves. It appears that the exhaust is this valve, intake is here, and it appears as though we'll rotate this and try to bring it up on top dead center. Looks to me like our exhaust valve is that edge is a little hard to turn. I've got a wrench I'll put on the flywheel here. No need to sweat and strain on this. Okay. Now the exhaust is closing. Okay, now the intake is opening. Okay, and it should be, as we come up this time, I'm going to stuck a screwdriver here and try to feel the piston coming up. Alright, this should be compression stroke, and we're going to see if we can get this thing right on top dead center. Alright, let's see if I can roll that a little bit with my hand. Okay, that feels like very close top dead center. And I had just roughed these in earlier, and they're They do have a little gap, but the specifications call for 4/1000ths of an inch, both exhaust and the intake. And this one seems just a tad tight, so I'll loosen that just a bit. Needless to say, I got that just a tight bit, and we've got a jam nut down below that needs to be tightened. And let's see if we still have our clearance or not. Yes, that feels pretty good. That's about right. Alright, let's go to the exhaust valve, and again 4/1000ths on that. Ooh, this one feels like it's just about right on. I'll go ahead and try to just tighten the jam nut on that. A little tight to get your wrench in there. Okay. Oh, that got a little tight on me. Back that off just a tiny bit. Okay, that feels pretty good. Alright, we should have the valve set now. This would probably be a good time to do a compression check on the engine. We haven't set the carburetor or the exhaust system yet, but if we need to take it back apart again, I guess it's better to find out now rather than after we have the thing completely assembled. I'm going to go ahead and put the pull start on. Okay. This wasn't done, the first pressure test wasn't done on camera, but we only had about 22 or 23 pounds of pressure. Compression, which of course indicated we had issues. These have O-rings on them, so they don't need to be extremely tight. So right, we'll give it a pull here and see what happens. Uh-oh. Well, this was my favorite pressure. As you can see, pressure's zooming up to about 30 pounds and then bleeding off. Apparently, I've got a leaky hose. Got another. Alright, well, maybe we'll get a test. Let me try a second compression tester here. I'll also try to be a little more careful not to slip the hose. Alright. Well, we'll just have to give it a whirl here and then check it. Hopefully it'll hold pressure. Alright, yes. We've got about 50 psi. I'm sure this engine has being a 12 horsepower, I'm sure it has a compression release, so anywhere in the 50 or 60 psi range is pretty good. Much better than the original test at 20 psi. So I would say our valve work has hopefully solved that problem. So next step is to start putting the carburetor on, the exhaust system on, and maybe we'll give a test to see if this thing will actually come up and run. Okay, now the new carburetor is got a slightly different throttle linkage arrangement, so I'll just have to set it on here and see how it goes. We'll go ahead and just slip this on for the time being. Okay, well, we have run into a bit of a snag here. Well, I'm going to have to go away and think about this. I'll get back to you later. Okay, had to make some modifications to the carburetor. And yes, this is a little Rube Goldberg, but basically you see a steel plate here that was put on top of the original rotator arm. This is the original carburetor, and the linkage originally attached itself right here and pushed this open. Unfortunately, the new carburetor had an arm that came out here to here, and I tried drilling a hole in the shaft about where this dot is that you see here, but the problem was as the throttle opened up, this arm In fact, it's a little further over than what's shown. This arm would hit the center of the shaft, and it would be locked and couldn't push the throttle the rest of the way open. So I was assured that this replacement carburetor is supposed to fit this particular unit, but I guess we all fib occasionally. Also had to lift up the arm of this when this is in the full choke position. You can see that this just about interferes with this arm, but fortunately I could just bend that up slightly and get it out of the way. So I don't anticipate that to be a problem. So if this was again put on with a little bit of J.B. Weld's steel stick, sometimes this gets you out of a tight spot, sometimes it doesn't, but I don't anticipate. This should be stable to about 450 degrees, and if the carburetor gets to 450 degrees, well, I've got a lot of really serious problems. So unless the vibration causes the part to come loose, hopefully I've got a solution here. And with that, I think we're ready to try to get this unit up and running again. Hopefully. We'll see what happens. Fuel is on. Choke is set. But as usual, it was a little temperamental to start. However, when I went around and pulled the start lever, one real improvement I noticed that there's quite a bit of weight in the arms of the cutting blades, and when I pull this in, always before I'd have to kind of just barely touch the clutch on the rotating part of this and get the blades rotating before I could pull it all the way back. But you may have noticed I pretty well just pulled back. You heard the engine load up as it took it in stride and started, so it's developing more power than it used to. I'm well pleased with that. I believe I'll go ahead and try putting the air breather on, and we'll try to start it again. I know that one of the things that happens when I don't have the air breather on is that the unit does tend to run a little lean. don't know if that'll make any difference in the way it starts or not. It may just be that way. I've always, particularly in the wintertime when I use this unit, I've almost always used starting fluid. And well, let's give it a try. Still hard to start. Probably have to kind of take a look at that. Well, it started with the choke fully open. Maybe I was flooding it just a bit, but this hand pull starting for a 12 horsepower engine gives you a real workout. It actually has teeth on the flywheel for starting motor, electric starting motor. It would be nice if it had it, but apparently they decided that it didn't need it. Guess I'll give it another try and see if it'll get up again. Well, it's just hard to start. I think I'm going to call that a wrap. Well, I was not too pleased with how difficult it was to start this unit, so I began to do a bit more checking. This has got a intake manifold here. It goes up, it's about 6 inches long, and then it bolts into the cylinder head on this side. And so I was tinkering with this, trying to see if I could get it to run and start a little better. And I noticed that right here in the flange, I could see signs of leakage. Specifically, when it backfired a couple times, I saw some fire through the crack there. So I knew that gasket wasn't doing its job. It was the gasket that came with the carburetor. However, it just wasn't good enough. So I went back, took the intake manifold off, put a little silicone sealer both at the connection to the head, and then added a second gasket here and put silicone sealer on all surfaces on the two gaskets, put it back together, and seems to start and run much better than it did. Actually, it ran okay. It was starting that is a real issue. So we'll give it another try here and see how it does after these changes have been made. Glad you came along on the repair journey of my wood chipper. I pulled my chipper into the shop to remove old gas and install a filter and gas drain valve to make future maintenance easier. It was a 20-minute project tops. But when that was completed, the engine wouldn't start, so the carburetor was taken off with the intention of being cleaned. However, problems were observed in the old carburetor. A new carb was ordered, but it was not an exact replacement for the original, so changes had to be made in the linkage. The engine still did not run properly. Compression was checked and found to be low. First valve clearances were checked and found to be acceptable, so the problem almost had to be in the cylinder head. The cylinder head was removed and no obvious problems were observed. However, a leaky cylinder head was suspected. The valves were lightly lapped and the cylinder head was, with new gasket, was reinstalled. I purchased a cylinder leak down tester and used this device to check the cylinder once the cylinder head was reinstalled. A significant leak was found in the intake valve. The cylinder head was again removed. Both the intake and exhaust valves were ground or lapped to correct the leakage issue. On reinstallation of the head, both the cylinder leak down test and a compression test were performed. The results of both tests were normal, so the engine was reassembled. The engine ran well, but was still difficult to start. Finally, it was discovered that air was leaking into the intake manifold downstream of the carburetor. This problem was corrected by adding a second carburetor gasket and applying a thin coating of silicone sealer on the faces of the carburetor and the gaskets. Now all seems to be well, as good health has been returned to my chipper. Thank you for watching.